All right, let's talk about target pricing and therefore target costing. There are 5 steps that we have to go through if we are going to use the target pricing. Number 1, we have definitely got to develop a product that satisfies the needs and the wants of the potential customers. Again, we're going to talk here in a little while about value added and non-value added. And we've got to keep in mind that we have to view our price and our product from the eyes of the customer. Okay, so if we are going to be giving them more product attributes than they are willing to pay for, then they're not going to buy it. So we just need to satisfy what their needs or wants are. We don't necessarily have to over-deliver, because with over-delivery, there are costs. And if they're not willing to pay the price for that, then we need to back those prices down, at the same time backing off the cost of those additional attributes by way of taking those attributes away. Number 2, we will choose the target price. And when we're talking about target pricing, I want you to imagine, if you will, a bullseye. If we are having to consider the market's price for our product, then that is our target. And we're going to shoot for that. We're going to back off our profit and then figure out what we have to have cost-wise in order to obtain not just the market price, but also that profitability. We're going to derive the target cost per unit by subtracting the target operating income per unit from the target price. So in other words, we're starting at the target price and backing our way through the process of costing. We will perform cost analysis, and we will perform value engineering in order to achieve that target cost. All right, so we're going to start with our target price, which is the estimated price for a product or service that potential customers are willing to pay. The target price is estimated based on an understanding of customers' perceived value for a product or service. Again, from their viewpoint, what are they willing to give up of their money for your product or service? How our competitors are going to react. How are they going to price their competing products or services? All right, so let's first take a look here at our data set. I want you guys to keep in mind that what we're first going to look at is current conditions. What have we been selling our products for? What have our products been costing us to produce? And then we're going to look at analyzing the market, considering our competition, considering the customers and what they're willing to pay and what they want. And then we're going to come up with a price, and then we're going to evaluate our cost, and we're going to figure out what we need to do in order to get our cost lined up with our target price and our profitability. And then what do we have to do to optimize our operations and the production or manufacture of that product in order to make this plan happen. Okay, so here's our data set. This is the one that's showing up in our 15th edition text. It's on page 520. All in all, we're trying to use our long run pricing here. And this particular company is named Astle, and we're looking at one particular product, and it's called Pro Value. The direct material cost, the total, varies with the number of units of Pro Value produced. You guys can see here that we have typically been generating 150,000 units of this product, Pro Value. And each 1 unit of Pro Value needs 1 kit of direct materials. And those direct material kits are costing us $460 per unit right now. The direct manufacturing labor cost, those are going to vary based on the number of direct manufacturing labor hours used. Right now, for each unit that we manufacture, it's been taking us 3.2 hours per unit at $20 per hour. All right, so we can see if we take 150,000, multiply it times 3.2, we have 480,000 hours at $20 per hour. Next, we have our direct machining cost, and these are actually fixed costs. So I want you to notice we have not gone through and broken this down on a per hour basis. All right, we have signed some leases to the tune of $300,000 for, actually it's not $300,000, it's a certain dollar amount. Let's see. Our machining cost. We have signed leases for $11,400,000 for the year, and that covers 300,000 machine hours. Okay, so we've signed these leases, and how we utilize the machines right now, we're saying we're using all of the 300,000 machine hours. If we break it down on a per hour basis, it is $38 per machine hour. Our ordering and receiving cost, we have to place orders, and we also have to receive those orders. And we have so many components that go into our production or manufacture of Pro Value. Okay, so for each component that goes into our item, we have to place an order. And we are saying that we've got 50 orders for each component. So let's just say we're not doing production for the week of Christmas and New Year's. We're shutting down the plant, so we're taking off 2 weeks for the year, but the other 50, we have a weekly order for those components. All right, so 50 orders during the period times 450 separate components that have to be ordered. Alright, so 50 times 450 means 22,500 total orders that are placed, and we're saying it cost us $80 to order and receive each one of those. Our testing and inspection, we have got testing hours that need to be utilized for each unit, and we have 150,000 units that we are producing. That is a lot of hours per unit for testing, but we'll go with it for the example. All right, so 30 hours per unit times 150,000 units that we produce equals 4,500,000 hours at $2 an hour for the testing and inspection. We saw that sometimes things do not work out as planned, and we have to do rework. That was covered and discussed in chapters 17 and 18. This particular company has a defect rate of 8%. All right, so based on our 8%, we are expecting 12,000 defective units. And each one of those units is going to require 2.5 hours of rework. So 2.5 hours times 12,000 defective units equals 30,000 hours needed for rework at $40 per hour. All right, so this is how we are currently doing. This is our expected cost based on everything, how we have it set up right now. All right, this is where our baseline. Well, this is our total cost that we would be looking at And this is just to manufacture the goods, okay? So this is taking the data that I just went over and multiplying it out times our 150,000 units, the number of hours required to do them, and all of those ordering and receiving costs, plus the testing and inspection cost, plus the rework cost. This is what it currently costs us to manufacture the items. Notice right now that this is $680. And we're actually selling all of those units. They cost us $680 to make. But we know we have other costs that we incur above and beyond these manufacturing costs. Which brings us to the next set of information. We are currently selling these units for $1,000 a piece in the market that we compete in. And the cost to manufacture them is currently $680 per unit. But we have other costs that we incur above and beyond manufacturing. Therefore, they are relevant in our long run pricing. We spend $2.4 million a year on research and development. We have $3 million in design cost of the product and the process that we go through to manufacture it. And they're missing an S here. That needs to be corrected, but I can't correct it myself. I can't go in and alter their slides. Marketing and administration cost, $15 million. Distribution cost, $9 million. Customer service cost, $3.6 million. I want you guys to consider the value chain for an organization and notice that these are the remaining underlying aspects of that value chain. Okay, so over the long run, we're considering every cost that we incur in our pricing decisions. All right, so our full cost of the product is actually $900 per unit, not just $680. Okay, we are ignoring taxes, etc., etc. Let's just look at our operating income and operating cost in addition to cost of goods on those items. In implementing our target pricing, we have 5 steps. Develop a product that satisfies the needs of the potential customers. Altering the product if and when necessary. Here in our particular example, these customers that we have as our target market do not necessarily want all of the features or attributes that we have attached to this product. Therefore, they are not going to be willing to pay for those additional bells and whistles. So, if we're going to change the price, we also need to change the attributes. So we can alter the product and the price that we charge for it. Under our current example, we are going to be removing some of the attributes and we are going to be changing our target price from $1,000 per unit down to $800. We just saw that right now it costs us $680 to manufacture and a total of $900 per unit when you're looking at the long run cost. Okay, so right off the bat, alarms should go off in your head. You had now got a price that is $100 below your long run cost. So you know right now your company has got a lot of work to do in order to get all of those costs down. All right, so we are going to step 2 from that, derive a target cost per unit by subtracting the target operating income per unit from the target price. We're going to perform a cost analysis and we're going to perform value engineering to achieve target cost. These actually need to be renumbered. Okay, so go with it, folks. This should be 1, 2, 3, 4, 5. Value engineering. We need to reduce our cost in order to make that selling price of $800 be profitable for us. So value engineering is what we incorporate into how we run our organization. Value engineering is a systematic evaluation of all aspects of the value chain with the objective of reducing cost and achieving a quality level that satisfies customers. Value engineering entails improvements in product designs, changes in material specifications, and modifications in process methods. When we talk about improvements in the product designs, we want to make the products better. We also, however, want to make sure that we are not incorporating in our production processes that are not adding value to the product, that are not optimized or efficient. Are we incorporating materials into the product that could be done a better way, better quality, less labor hours, less machine hours? What kinds of things can we do to tweak the product design, to tweak the manufacturing design, to reduce the number of materials that go into the product, to reduce the labor hours, to reduce the machine hours, to reduce the utilities, to reduce the square footage of production facility space? What kinds of things can we do better? That is value engineering. And it's going to take more than just the engineers to sit down and go through all this. We need the accountants. We need the production people. We need the engineers. We need management. We need the purchasing people. We even need the marketing and sales people. Everybody needs to be giving us input in our value engineering process. All right, so to implement value engineering, managers have to distinguish between value-added activities and components and cost from non-value-added activities and components and cost. Value added from the eyes of the beholder. All of these costs are being incurred in every single area in the value chain. Again, everybody that has anything to do with these specific areas needs to be giving us their information. Start a suggestion box. People can come up with some really good things in order to improve your company's bottom line. Have an open door policy. Listen to what your line workers have to say about making your company better. Value added costs are costs that, if eliminated, would reduce the actual or perceived value or utility or usefulness of the customer's experience from using the product or service. So, value-added costs are costs that we incur for the benefit of the customer, and the customer is willing to pay for those. It's adding value to the product or the service, and the customer appreciates that value. Okay, so they're willing to pay for that value. On the other hand, non-value added costs are costs that, if eliminated, would not reduce the actual or perceived value or utility or usefulness that customers gain from using the product or service. It is a cost the customer is unwilling to pay for. Examples include the cost of defective products and machine breakdowns. If you guys were to go back and look at that data set that I just showed you just a moment ago, what did we have in total cost just for rework? Just for rework, $1.2 million. The customer could care less about covering that for you. And that is embedded in the sales price. Okay? Non-value added. We need to optimize our operations. We need to be more efficient. We need to be more effective. And how do we do that? We need to work on these areas that are non-value added. Fix them. Reduce those costs because the customers do not want to pay you for that kind of stuff. Cost incurrence describes when a resource is consumed or the benefit foregone to meet a specific objective. When are we incurring that cost? Locked-in costs are something we have got to pay a lot of attention to. Locked-in costs are designed in, and this is where value engineering and getting all of these people together to discuss how to do everything better comes into play. Because the majority of our costs get locked in well in advance. These are costs that have not yet been incurred, but trust me, they will be in the future based on the decisions that are made. Alright, so locked in cost versus just costs that are going to be incurred based on somebody issuing a purchase order for something later. These are things that are locked into not only how the product is designed, but the process of putting the product together. How's the assembly line going to work? How much facility space is it really going to take? All of these things are long run in nature, locked in for quite some time. So the best opportunity to manage cost is before they are locked in. In your book, it shows you that you can graph out the locked-in cost curve and the cost incurrence curve and see what a predominant amount of costs are locked in. Alright, so in regards to our particular example, the Pro Value product, in discussions with our customers and our marketing and salespeople, we have determined that our customers do not really care for some of the extra features that we have made available in the $1,000 per unit component of Pro Value, and they are willing to accept less features and attributes in order to be able to buy it for a lower price. So we are going to take some of our items or attributes off, and we are going to lower our price. We have also considered our competition, and we believe that they are going to be offering a similar product to ours, and they're going to be offering it for $850, and we are going to respond aggressively and go from $1,000 per unit down to $800 per unit. When we do this, we actually expect or are forecasting that we will sell more units. So from $1,000 down to $800, we expect now to sell 50,000 additional units. So instead of 150,000 units, we're actually going to sell 200,000 units. So we're going to reduce our price, reduce some of our costs by eliminating some of those attributes that customers do not perceive as valuable from their viewpoint. And we are now going to go about performing target costing. So we've got our target price of $800. Now we need to calculate what cost do we need to be able to do this product for. All right, so revenues times 10%. 10% is our target operating income per unit, and therefore that comes out to $80. Okay, so $80 out of $800 is our target operating income. So that means that the remaining 90% are our cost. And we're not just talking about the cost to manufacture, we're talking about all of our costs, the long range version, okay, where all of those costs are relevant. So to calculate that target cost per unit, we're just going to take the revenues and subtract that target operating income per unit to give us a target cost per unit of $720. All cost included, $720 per unit. What have we just seen? $680 was the cost to manufacture, but $900 was the cost per unit, all inclusive. So we have a long ways to go. We've got $180 that we have got to shave off by some means. So we will go through value engineering and we will figure out what it's going to take in order to obtain that target cost, and we will pay very special attention to the locked-in cost. So in doing so, the company is going to figure out a way in order to obtain this. All right, so we can use simple, more reliable motherboard without complex features to reduce our manufacturing cost and also our repair cost. This is for our Pro Value Model 2. We are going to do these things. We are going to snap fit together parts rather than solder them. And soldering them is kind of like a miniaturized version of welding, if you will. All right, so that's going to decrease our labor hours and related costs. We're going to use fewer components. Recall that we said it was like $80 for every order that we had to place for those components that we had. We can even reduce the number of times we order and receive parts. Okay, we of course would want to consider just in time. We would want to consider quality. We would want to consider inventory carrying cost and all those other things that we've seen up until this point in this course. So there's a lot to consider when you're talking about ordering your components, supplier reliability, et cetera, right? We would also attempt to make our product lighter and smaller in order to reduce our distribution costs, those freight out expenses, our packaging cost. For those of you who have not really worked in industry too much, if you are shipping out items such as a laptop computer of some sorts or other types of items, companies such as UPS and FedEx do charge not just by the pound for the shipment, but they also charge insurance for those packages based on the value of the package. They also charge additional handling fees for things that go beyond a specific length and girth, and even for packages that are heavier than a certain pound, for example, above and beyond 70 pounds. So all those things need to be considered when we are working on our value engineering, and we need to pay very special attention to the items that can be locked in, parts, processes, etc. So once our company has gone through and done that, they are going to be shooting for some new and improved numbers. Earlier we had seen that we had such things as the machine hours that we had leased for 11.6 million, 300,000 hours worth of machining. Well, Astel is going to make some changes to their manufacturing process, and they are actually going to be able to produce these 200,000 units by optimizing their capacity without having to lease any additional hours. So notice that they are still going to be using the 300,000 hours, but we're going to be getting 200,000 units instead of 150,000 units out of that capacity. We're not going to be able to reduce our direct manufacturing labor hour rate. We're not going to be able to reduce our $80 cost per order or our $2 cost per testing hour or the $40 cost per rework hour, but we are going to make some changes in other areas. Alright, so we're going to be able to reduce our direct materials and component cost. We are going to be able to reduce our direct manufacturing labor hours required and testing hours required. And we're going to have our non-value added cost by simplifying the design, help us to reduce the rework that's required. Alright, so we've got all kinds of things that we can do in order to optimize our operations, and we are actually going to pull that off. Prior to this value engineering, our per unit cost to manufacture was $680, but once we have actually gone through the steps of value engineering and optimizing our processes and reducing the number of components, reducing manufacturing times, etc., we can actually get it down to $540 per unit. Alright, so we're going to shoot for these. This is going to be our target. This is going to be our budgeted amounts. And we will reduce our selling price to $800, put into play or implement all of these changes, and work our way towards meeting these targeted costs. And then at the end of the period, we will circle back around and see how everything worked out for us. We do have some issues that we might need to consider when we are putting in place value engineering. There are some possible undesirable effects. Unless the process is managed well and properly, then value engineering and target costing can have undesirable effects, such as employees may feel frustrated if they fail to attain targets. These improvements in efficiencies, etc., need to be attainable. They cannot be a pipe dream. Okay, so that's another reason why you've got to have input from all the different areas. These have to be attainable. Okay, so if they're not attainable, your people will get frustrated. The cross-functional team may add too many features just to accommodate the different wishes of team members. So we have to do this in an orderly fashion. We should prioritize what we are able to accomplish, and we may need to spread these out over time and make a longer range plan to implement these changes and work on them over a longer range. A product may be in development for a long time because we all know what happens when a lot of people get together and everybody wants something different. And we have to spend a lot of time negotiating and arguing over the best way to do something. And if we're not careful, this can take longer than necessary in order to do. So we have to be careful. We have to prioritize, figure out the best way to do it without taking longer than necessary. Organizational conflicts can develop as the burden of cutting cost could fall unequally on different business functions in the company's value chain. So management is going to have to set the tone for the discussion, and they may have to be the ones to make the final decisions, but management needs to consider how it is going to actually affect the different areas of the value chain and their respective managers. To avoid those possible undesirable effects, target costing efforts should always encourage employee participation and celebrate small improvements toward achieving the target cost. Always continue to focus on the customer because it's all about what they are willing to pay us for the products. Pay attention to schedules. I have mentioned to you all before additional things that you can do to further your career above and beyond such things as the CPA and CMA certifications. I've discussed sharpening your Excel skills. You guys can also go out and get a professional certification for project management. Keeping a project on schedule and within or under budget is something that employers are willing to pay for. Okay, so if you are one of those individuals that plots out your syllabus schedule on calendars and you keep up with when homework is due and you are proactive in staying ahead of how you do your work and study time and all of that, then you are the kind of person that may want to pursue a project management certification. And I can tell I've got a few in this particular class based on when I refresh the grade book, who is staying on task and staying on schedule and not waiting until the last minute to do stuff. So you guys might want to take a look at that. Set your cost-cutting targets for all value chain functions to encourage a culture of teamwork and cooperation. All costs are relevant across the value chain when we are talking about long-range planning, and everybody contributes to the bottom line. So let's get everybody to work towards a common goal. I did want to bring in here the fact that a lot of what we're talking about in this particular chapter is relative to the use of the balanced scorecard, which we will talk about more in one of our future chapters, but I want you guys to just take a peek here at the fact that the internal process portion of the balanced scorecard talks a lot about some of the things that we have seen. We are shooting for less rework, less defective components, less defective products that we are putting out, because we know those cost us money in rework, in customer complaints, those types of things. So stock outs, we've talked about inventory management. We know that we cannot run out of stuff. Our labor utilization rates affect, of course, our total cost. How effective are they in producing our products? Waste reduction and planning accuracy, all of these are incorporated into our target cost area.